Okay. So a 3 kilowatt heater heats a bedroom for 1 hour. How much work is done? Okay. So power is work over time. So work is power multiplied by time. It's 3 kilowatts. And the time, what's the time? 1 hour. How many seconds? 3,600. So you get a big number. 10.8 megajoules. Oh, by the way, you share your home and you share your home. Homestay or apartment? Apartment. Um, so he homestay or apartment? Homestay, and for you?
Apartment.
Apartment. So you two get electric bills?
No, I stay in the accommodation, so it's all like prepaid.
You too? Okay.
I don't have electric bill.
You get electric bills. So just as a matter of interest, when you look at your electric bill, they use something called 1 unit of electricity. So 1 unit, if you want to know what that is in physics, that is 3.6 megajoules. So if they said you used, for example, 100 units of electric energy, that means you've used 100 times 3.6 megajoules. So this is actually normal in most countries, that for electric bills they charge you per 3.6 megajoules. I think this is about 25 cents for 3.6 megajoules.
But it's 3.6 megajoules per hour.
No, this is just megajoules. Doesn't matter about the time. You're thinking of kilowatt hours.
Yeah.
It's a different way to measure it. The easiest way for me to think about it is they charge you for how much electric energy you use. So they charge you so once you clock up 3.6 megajoules, regardless if it's 1 hour or 10 hours, that's a unit of electricity. Yeah.
100 units of a month, we can say.
Huh? Oh, yeah, whatever, per month.
Yeah.
So I think 100 is actually too small. I think most people, well, no, actually, most people maybe would use about 200 or 300. About, okay. Anyways, that was just for a matter of interest. A forklift lifts 200 kilograms of potatoes a height of 1 meter in 4 seconds. What is the power of the forklift? I should have said at a constant speed, but oh well. So you have here 200 kilograms, and then it gets lifted up, and the distance is 1 meter, and the time it took to do this was 4 seconds. Now the weight here is 200 G, and the weight here is 200 G. So if the forklift lifts the potatoes, how much force does it need to lift the potatoes? It needs at least 200. Maybe it's like 201 or something, it doesn't matter, but at least 200. Okay, so work, sorry, do I want the power? Yeah. Power is work over time. Now, how much work has been done? You can think about this two ways, okay? You can use the formula work equals force times distance, because do you know the force? Yes. And do you know the distance? Yes. 1 meter. So you could use this formula, or you could also say that the work done was to give potential energy to the potatoes. So which formula do you prefer to use here? FD or MGH? MGH? Okay, so this will be MGH over T. 200 times 9.81 times 1 divided by 4. So you get about 491 watts.
419.5.
Okay, okay. If that makes you happy,
Yes.
great. I'm glad it does. Okay. A 50 watt TV has efficiency of 30%. How much light and sound is produced in 1 hour? So this TV here, the power that goes in is 50 watts. But 30% of it is the light and the sound. But how much is wasted?
70%.
70% is wasted. As what form? Heat. Yeah, so I want to know how much is wasted in 1 hour. So what is 70% of 50? Well, that's going to be 35, isn't it? Yeah. 35 watts. So that's like the power for the heat which is wasted is 35 watts. Power is work over time. So the work, but this is wasted work, is 35 T. What's the T? What's the time? 1 hour, is it?
Yeah.
Is it 1 hour?
Yeah.
So 3,600. So this will be 126 kilojoules of wasted heat energy work. Yeah? You got the same? Great.
1.2
Mega?
multiplied 10 over by.
Yes, also fine. Next one? Yes?
No.
No? Your mother left last night or yesterday morning?
Day before yesterday.
Oh, Saturday afternoon. She's home now?
I need 1 more week.
You need another week. Oh, yes, I understand. Okay. Um, Brakes on a car are 0% efficient. They produce no useful output of energy. Right, so first thing, which number is this now? 4. So you have your brakes here. What did I say the mass of the car was?
150.
1500, and the speed? 120. Now we need to make that meters per second. So I think we've seen this one a couple of times. 33.3 meters per second. So you get a big number again. The kinetic energy is 0.83 megajoules. Now, when you use the brakes, all of this energy goes into heat. So it's all wasted. So your brakes here, amazingly, they are 0% efficient. All the energy is lost. 0% efficient. Now, the hybrid cars, do you know hybrid car? Like Toyota Prius, Honda Civic hybrid as well.
No.
The one runs on battery.
You see the car I drove? You know when I nearly killed you coming into the school. Remember? Remember that morning? Yes. That car is a hybrid. It has an electric and a petrol engine. So what happens is when you stop the car, some of the energy from the brakes go into a battery.
What?
Yeah, when you put your foot on the brake, some of the energy from the brake pads go into a battery. Do you understand what I mean? The energy is stored to be used later. So when you put your foot down and stop, some of the energy goes into a battery. And some of the energy is wasted as heat. So I said, okay, if the efficiency is 10%, how much energy can be stored?
90%.
No, 10%. 10%.
Yeah.
So the formula is the useful over the input times 100 is the efficiency. So the useful over the input times 100. So you have 30 equals what you don't know. Oh, no, sorry, not 30. 10 equals x over 0.83 times 10 to the 6 times 100. So you get your answer of 0.083 megajoules, which, what is that? That is 83 kilojoules saved.
That's efficiency.
That's how much energy is saved from the brake pads.
Okay.
We can calculate in this sense like 10% of
Yeah,
kinetic
same
energy.
thing. Yeah, yeah,
Same thing.
yeah. Huh? This energy here is how much energy is saved from the brake pads, not wasted. It's put into a battery. So then later, when your car goes up a hill, the energy that was in the battery helps. And when you go down the hill, the opposite. The energy goes into the battery. So when I have one of these cars, and when I'm driving the car, when I go downhill, there's a little picture on my dashboard, and when I go downhill it says battery charging up. And then when I go uphill, then it says battery discharging, because the battery is helping the car go uphill. Likewise, when I'm on the motorway, and then I put my foot down to drive around someone, what do you think the battery does? Charge or discharge? Discharge. Okay. Then when I stop, as I'm stopping, I can see it says battery charging. So in this way, you can get some of the energy back from the brake pads. Yeah. So it's a good idea. It's a way to save energy because a lot is wasted. It does. It does.
But then don't you have to change the battery every like couple of years?
The battery's supposed to last for 8 to 10 years, so that's okay. I think it depends how much you drive as well. No, you are right though. The battery would need to be replaced eventually.
And they're really expensive, right?
They are 2,000 for the car battery. It's a special battery that can charge really quickly, discharge really quickly.
Which type of battery this
Oh, it'd be some fancy battery. I don't know. Some kind of super lithium battery. I don't know. It'd be a very fancy battery. Very fancy battery. So I mean, it's 2,000, 3,000 euros. It's not a normal lead car battery. Okay, did you get this one? Yeah.
You can scroll down a little bit.
To where? Oh, sorry. What's wrong with you? Do you have class at 9 o'clock?
Yeah.
Which class?
AP.
I understand what's wrong with you. Oh, writing exam. Oh, nice. What was your topic? Boring. How technology changed over 10 years? 20 years. In the future or in the past? In the past.
No, I mean,
Were you alive 20 years ago? You were alive 19 years ago, okay, but not 20 years ago, okay. You were born 20 years ago, okay, yeah. So you don't remember the technology then? Yeah. In pictures, yes, yes. Yes, television, yes, yes. Yes, yes, yes. History book. Okay, can I go to the next one? So, I think we're back to car. Ah, yes, the last one is a little tricky. Yes, yes. Did anybody get it? Okay. So you have an engine, 9 kilowatts, 25% efficient, and it's moving up at 10 meters per second.
yeah, number 5.
Oh, sorry. Of course. Ah, yeah, okay. Right, number 5. So you have your student, and he eats some food. Yep, that's my student. And he has his food, and it's 7.2 megajoules of energy in his stomach. Now, he goes to the gym. Do you know this word? Yes? And then he does some exercise, and half of this energy is converted into kinetic and potential. So he's at the gym, and he's doing his exercises, and he's doing his his squats. Yeah, and maybe we can have him jumping up and down, and he can do a cartwheel and all this stuff. So he has all this kinetic and potential energy, but of course not all of the energy becomes kinetic or potential, because what else happens when you're exercising? You get heat. So some of this energy is wasted. So in the question I said half of the energy becomes kinetic and potential, but then half of it becomes stinky heat. Stinky, smelly heat. Okay. How powerful he is. Okay, so efficiency equals 50%. So 50 equals the power out over, the work in times 100. So you get 0.5 equals W out over 7.2 times 10 to the 6. So his output is half of 7.2, basically. 3.6 times 10 to the 6 joules. Now I don't want the work. What do I want? I think I asked for the power. How powerful is he? So what's the formula for power? Well, that's just work over time. Do I tell you the time?
Yes.
1 hour, is it?
Yeah.
So 3,600. So the answer is 1 kilowatt. Yep.
If I just answer it like without the kilo, just
No, I need the unit. Oh, as 1,000 watts? Yeah, that's fine. Yeah. Yes. Okay. Next question. Yeah. Let me see. The car. Yeah. So this is number 6. So you have a car going up a hill. So there's a force here. The mass is unknown. The speed is 10 meters per second. The power of the engine is 9 kilowatts, and the efficiency is 25%. Okay, so the first thing I want to do is work out the power output of the car, because not all 9 kilowatts is used. Most of it is heat. So we have 25 equals power out over 9,000. So therefore power out is going to be 2.25 kilowatts.
Didn't we multiply by 100?
Oh, sorry, thank you. Well, I still got the right answer though, but yes. Is that part okay? Yeah. Now, the question is what? I forget. Oh yeah, so the first question is, why is the vehicle moving at a constant speed and not accelerating? So why do you think this is not accelerating? Why is it moving at a constant speed?
Because engine has to
The
work
engine is
hard.
supplying the same amount of power.
No, you're getting confused now. Newton's first law, it will only accelerate if there's a force.
Yeah.
If it's not accelerating, there's no force.
No.
So there must be a force this way to cancel this force. So it only moves at a constant speed. Yeah? What is this force? Well, that's the weight and the air and the friction and all this stuff. Okay. Here I want you to calculate the F. Okay? So there's a little trick to this. Can I go down? Yep. Okay. So power equals work over time. But what's the formula for work? Yes, and another formula?
Force into distance.
Force multiplied distance. But look here, what is distance divided by time? Speed. So you have power equals force multiplied by speed. So then what does force equal? Power divided by speed. Do we know the power? Yes. And do we know the speed? Yes. So we can know the force. Now this was tricky.
Yeah.
It was tricky. Can we go back?
Yes.
Yep. So here this will be 2250 divided by 10. So that is 225 newtons. Okay. So the last part is how much was wasted during the 10 seconds of motion. Okay. So look, this is what the engine makes, but this is what the engine does. So how much is wasted? It would be 9 minus 2.25. So that's 6.75 kilowatts. So power is work over time. Work, wasted work, is power, wasted power multiplied by time. 6750 multiplied by 10. So that's 67500. So that's 67.5 kilojoules of wasted heat. energy?
No.
Yeah.
Like, what needs to take place now? Like, what is the
The question was how much energy was wasted during the 10 seconds of motion up the hill. So I just did 9 minus 2.25 to get the wasted power, and then powers work over
This is
time.
total wasted power, or not just we are mean as for the first 10 seconds.
Yeah, yeah.
But it is the total power wasted. Like,
Well, that power wasted is basically saying per second how much energy is wasted. Because remember, power is just energy per second, work per second. Question?
No.
You got it right?
No.
Did you write it down?
Yes.
Good. Okay, can I close this?
5 minutes break.
Ah, no.
Yeah.
No,
Thank
you were late.
Just only
So they can have a 5-minute break and I
no,
continue
they have
teaching
a 5
you?
minutes. No, no, no.
But I want to do the next topic. Do you have a class after this class?
No.
Okay. I will promise to finish at 12:40.
I want to go to the toilet around 9 o'clock.
You want to what?
Go to the toilet at 9
Go
o'clock.
to the toilet. Go to the toilet and then when you come back we'll start.
Yes.
And don't take too long.
No, no, less than 5 minutes.
Less than. And don't just stand in there using your phone.
No.
Yeah.